Welcome to the yet another session on DWSim. This is the DWSim platform where I'm trying to open a new simulation window. And today I would like to understand the pure component, the phase. What will happen when the pressure is fixed and temperature is changed? How does the phase change? And at what temperature the phase is changing? For the purpose of example, I am taking today as acetone as the component. Okay, you can see right here. So I am taking acetone as a pure component first stage. Okay. In the later stages, I will try to take another what you call system, acetone plus methanol. So in continuation to this, I'll actually try to do this. So we can understand first of all how does the phase changes with acetone, and similarly we can work out with methanol also. These are the two pure components, but at the later stage, if acetone plus methanol is coming into picture, that is a mixture is coming into picture. What is the phase change? Rather, where between what temperature there is a vapor generation also coming into picture. So these are the what you call forthcoming sessions or simulations I would like to express. Yeah. Now let us actually quickly look at the acetone now. So this is so you can see here at this place. So this is introduction, and this is compound, this is property package, system of units, right? And this is the behavior. So these are the things which we need to actually specify before starting any simulation. Okay, so let's go ahead. So here, if you see, there is a what you call there is a next button here. So I click on next here. Let me take out these two here. Yeah, and now so click on next, and here if you can see this search button here. So this is the area where sorry, it's not the one, and the area what you see is here. In this we shall type acetone. Okay, acetone. Yeah, so see, acetone is coming into picture. Let me erase this particular arrow, and now we are in acetone. So click on acetone and go to next. Okay. Now let us choose one of the methods here. The simplest method, or rather we can take whatever. Suppose say if I take activity coefficient, I don't know whether it is not actually giving me anything, right? So let me take any equation of state. So you can see there are certain options here where we can choose, but for this purpose, for the present purpose, we can take one particular what you call thermodynamic package and then work on it. Okay, let me for as an equation of state, I would like to choose Suave-Redditch Const is available with us, and Peng Robinson is also available with us. Let us take Suave-Redditch Const equation of state SRK. See, this blue color, it seems it is available for the free open source, but green, it is not available for the open source. We have to go for the upgradation. So I add this, and at the bottom you can see here, this is, if you can see, SVLLE, VLE, VLLE, LLE, right? So we are interested in VLE actually. So vapor liquid equilibrium only, because acetone is a pure component as it is. It is a, I think you all know acetone is a liquid. Now I select VLE and then click next. Now system of units, it is by default it is SI. I take C5 and then keep the temperature as centigrade, and the pressure, let us change it to atmosphere for our convenience sake, because generally we use atmospheric pressure or when we specify. Mass flow rate is given as kg per hour. You can see here mass flow rate is given, volumetric flow rate is there, temperature is there, and molar flow rate is also available here. So these things are available with us. Okay. Now let us go to the next part, please. Now next part, right? This is by default. You don't have to do anything here. Just keep it like this. Now choose the material stream here. I shall choose the material stream. That means you have to click here and then drag it here and just keep it here. To maximize, just increase the mouse, and then I shall specify the. If I click on this particular stream arrow, directed arrow, I will get the details here. So if you can see, yeah, if you can see here, this is the object stream. Just let us say we can say acetone input. Okay, acetone feed. Let us say acetone feed. So immediately you can see now that it is changed, right? Now property package is given, and temperature and pressure as by default it is available. Let us say molar flow rate by default. Let us say suppose say 1 kilomole per hour as a basis. So based on 1 kilomole per hour, you will definitely calculate the kg per hour, meter per hour. Every calculation is available now. So as it is, what is the phase of the? See, you can see here at the bottom. If you can see at the bottom here, bottom of this particular, yeah. Now you can see here, by default, the vapor phase mole fraction is 0. That means it is liquid state. It is in liquid state. Okay, that we understand. Okay. Now, so as it is, if I click here also, and then see the results also. Suppose I drag it here and then come here and then put it. See the phases. What you see here, the phases at the bottom, it is shown as liquid. So that is what is happened, right? Now, all other things you can actually see. The temperature is 25 degrees centigrade. Pressure is given as pressure is 1 atmospheric pressure. Mass flow, molar flow, volumetric flow, molar enthalpy, molar entropy, molar fraction, phases, and energy flow. These things are available and can be seen. Now, what is our concern is that it is liquid state. Now, at what temperature it is changing to vapor state? Generally, when we are referring to a pure component, we know that at its boiling point, it will change its phase from liquid to what we call vapor. But how do we study that in this particular dataset? We will go to the flow sheet analysis, sensitivity study, and then object. So this is independent variable 1. So I create here acetone feed and property as the keeping the pressure constant. I want to change the temperature. So initially it is given as 25 degrees centigrade. I take it as the lower limit is 25, and the upper limit I will give it as, let us specify it as 75. And number of points between it is giving us like this. Let me take it as in interval of let it actually count like this, but let me specify 20. The dependent variable now, as it is, you cannot say let me go to this and the property. Let us work on it. Say, let me actually try to work on it. If we see what is happening here, so anywhere I can see the fraction or the mole fraction or something like that. Okay. So molar flow is shown. Molar flow is given. Molar flow, molar fraction. See. Now this molar fraction is coming here. This is actually this is molar fraction liquid. See, molar fraction liquid. Molar fraction liquid. I think this is not shown here, but we have to maximize the window or do those things like that. So let me take molar fraction overall. Okay. So let me keep it as molar fraction. So you can see. So this is the molar fraction overall, which is taken up. Now I go to the results, and then I start sensitivity analysis. It is actually doing it now. See, molar fraction overall, actually as it is, you can see it is liquid. Molar fraction overall, it is actually liquid. See, it is liquid. But it has somewhere it has changed from 1 to, see, now you can see, initially it is 25. At 25 it is shown the molar fraction of the liquid acetone feed it is shown here as 1. See, these are the molar fraction overall liquid. So this is the temperature 25, and it is starting from 25 to 75. At what temperature now our concern is where it is actually changing to 0. That means now you can see here this particular area, somewhere here, this particular area, right? Let me take another color, beautiful color here, purple. Okay, now this particular area 1 to 0, see, that means between 53 point, that means 53.9474 and 56.5789. See, so in between these two, that means there is a phase change. That means it is changing from liquid to vapor. So this is what we have to understand. Now, as it is, if I want to look at this chart, as per the chart here, what is happening? Let me actually take all this out here, and then so it will be easy. Now I say, let us say to draw. That means I say this is draw. Now see what is happening here. So let me, yeah. So this is the place. So till this temperature it is liquid. Okay. There it has converted into, then it has converted into, you can see, then it has converted to vapor. So this is liquid phase, this is vapor phase. One thing you need to understand, the boiling point of acetone is also very important. Near about it is 56 range. So this in between this. So this is the exercise where we are able to understand, or where what we have learned in this exercise is that how to build a stream in the process flow window, how to what you call give input as acetone, and how to change the system of units in this we have seen, and then thermodynamic package, which thermodynamic package to choose we have chosen, and then we have given the what you call the temperature and pressure as the inputs, and then we have checked what is the actually the fraction of vapor fraction. First it is shown as 1, and then when we are continuously doing it, and then the next step what we have done is the sensitivity analysis. Next step what we have done is the sensitivity analysis. So sensitivity analysis also we have taken up. That's through sensitivity analysis we understood. So next one what we did is sensitivity analysis. Okay, this also we have done. So see, sensitivity analysis we have taken from flow sheet analysis tab. Okay, so with this short video I close this here. Hope you have understood the what you call the lesson here, or the simulation package. We'll take up in the next package the mixture of acetone and the methanol. Okay, take care. Bye bye.